Okay, yeah, let's kick off another zero-to-quake-3 stream. So yesterday was a pretty good one. We got the model view projection matrices added into our vertex shader through use of a uniform buffer, um, which, just to recap, just gives us I believe it's a triangle at the moment that we do have the ability to kind of technically move around, although we didn't look at doing that in the previous stream. So I thought today we'll carry on with some of these progress items. Definitely get an index buffer added, which is going to allow us to basically upload less data to the GPU to render complex geometry. And then once we get that implemented, which I think is actually going to be quite straightforward, it's just another buffer object. Maybe try and introduce a depth buffer as well. So let's have a look at the index buffer first. So basically the idea of an index buffer is when you're rendering stuff on the GPU, you've got a big set of vertices essentially. And the GPU has to go through those vertices in some order to form triangles. Now you could upload every single triangle and keep duplicating the vertices, but it so happens that most 3D objects have a lot of vertices that coincide in location. So rather than uploading duplicate vertices, you upload unique vertices, and then you upload an index buffer as well that says how you should traverse through this. Well, it's essentially a list of vertices. So maybe draw vertex 0, 3, and 5, and then draw 0, 1, and 3 or something, and that might be two triangles that share a common vertex. And the Quake 3 BSP format uses exactly this, which is part of the reason I'm going ahead and doing this, although it's just more efficient in general to do rendering this way. If you've got the case where vertices are duplicated, which is pretty much always the case when you've got kind of planar surfaces. So walls will often share vertices down a common edge. So after I create my vertex buffer, I'm going to create an index buffer. And this is pretty much exactly the same as creating a vertex buffer. So we need a physical device, we need a device, we need some indices. Right now that's just going to be 0, 1, 2 to correspond with these vertices that we've got up here. Yeah, these are going to be pretty much the same. So we've got create buffer. Why don't we have create buffer from list? Oops. You know what? This is going to carry really nicely if we stick that right at the start. That means creating a vertex buffer is create buffer from list. Fairly anticlimactic, but creating an index buffer is exactly the same. But its usage is going to change. What is it going to change to? So that was VK buffer use. Yeah, cool. Index buffer bit. That takes maybe CM32. Word 32 would probably make more sense. They're unsigned. That doesn't exist. Cool. So, yeah. So let's create a buffer, allocate the memory for it, and map indices into it, but we need to use that. So we've bound our vertex buffer. Yeah, I'll leave that now. So now we're going to bind index buffer. So this isn't going to be bind vertex buffers. Is there a bind index buffers? Bind, oh, that's odd, I don't know why that didn't come up. Bind index buffer. Yes, of course, you can only have one of these. I was just in VK bind rather than VK CND bind. So command buffer, index buffer, the offset into it, and the index type. We are uploading uint32s, little overkill, but cool. And then the only remaining thing to do on top of that is to change our draw call to draw indexed. So let's hit command buffer, the amount of indices we're going to draw. So right now that's, we'll set up from length indices. One instance, the first index is 0, the vertex offset is 0, the first instance is 0, not sure about those. If tab completion wants to put that in the right place, that would be very much appreciated. That's fallen out of scope. So this should now look exactly the same as before. To double check this, we'll change this triangle to be a square, or maybe even a cube. We'll do a square for now. I think we'll then move it to a cube, and my plan then is to take the cube, try and rotate it, which is going to look really weird because we don't have a depth buffer, so all sorts of triangles are going to be weirdly overlapping. And then we'll introduce the depth buffer, and our cube should look kind of sensible. So good, that all works correctly. Let's change the location of some of these vertices to make a square. So let's put this at -1, 1. This can be at 1, 1, -1, and so what does that look like? -1, 1, 1, 1, 1, -1, -1. We're going in that direction, so we should then probably go maybe 4, 3, 2. hate coming up with these things by hand. It's always a bit of a strange visual process. Try and work out where the hell these things map up to. Okay, anyway, this, yeah, as I said, should give us just a red square. If I got that all correct. Doesn't. Minus one. I didn't really expect that triangle. So the triangle I expected would have a point here, here, and here to create one triangle, and then the other one should have been here, here, here. So that's surprising. Got a lot of things that I need to tidy up soon. Pop that into the plan. Done that. Cool. Bit of an aside there. So what the hell's going on here then? What happens if we draw just one of these triangles? Compilation times have got pretty bad now. We might benefit from that module structure soon because we're obviously compiling a pretty huge file. Might also look into using the gold linker, see if that speeds link times up. Okay, so this is the flipped y-axis that's surprising me. So yeah, of course, like Vulkan doesn't have a coordinate system, but for some reason we are getting this flipped matrix, flipped y-axis. Sorry. I think that's because of the normalized device coordinates. Yeah, we have a left-hand normalized device coordinate space in Vulkan. We have a right-hand normalized device coordinate space. I wonder why they changed that. Cool. This looks like I'm gonna have a read of this after this. Looks like some useful information here. We'll not worry about it for now. But that explains why the triangle is kind of upside down to my intuition. So in that case, if -1 is up, the triangle that I'm really expecting is 2, 3, -1, 1, 1, -1, -1, 0. How do we get the other triangle? That would be 1, -1, which is 3, down to -1, 1, which is 0, across to 1, 1, which is 1. That's the vertex we haven't used yet. Let's try that. There we go. So there's our square. Nothing too exciting, but that proves that the vertex buffer is working. So let's add that in. So the index buffer is working. Use the index buffer. So let's duplicate the set of vertices. Change this -5 to -1. And here I'm going to change the -5 to +1. Now I'm also going to take this and add 4 to everything. So what's that? 6, 7, 4, 7, 4, 5. Come on, Emacs. So the idea here is I got like two kind of planes, not really planes, squares with a bit of space between them, and that's going to let me test that the depth buffer is working. But right now this is around the camera. So if we view this, I imagine we're just going to see probably a red square, maybe even just blue if the camera's clipping it because it's so close to the camera. But what I'm going to do is push this away from the camera with a model matrix. We'll also change this, well, we'll have to work out how to change this model matrix, which we haven't done yet. Yeah, so there's like the big square, it's like directly in front of the camera. We're going to change this model matrix to rotate the object as well. Actually, we could do that statically, that might be kind of good enough. So let's push this away from the camera back into its rightful place. So I'm going to take that identity matrix and change its translation. And there's a lens for that, because there's a lens for everything these days. So we'll take the translation and set that to -5 units away from the camera. Let's go bring in a lens dependency. Transpose, translation. So yeah, so this now should be back to just being like a red square in the distance. Yep. So let's apply a rotation first and then translate into the distance. So for rotations, I can do M33 to M44, I think. M33 to M44. The reason I'm going to do that is because I'm going to represent my rotation as a quaternion, and that translates to a 3x3 matrix. You generate one of these, rotation to a vector, builds a quaternion representing rotation around an axis, which is exactly what we want. So get an axis angle, and I'll just do this through 111. Don't know if I need to normalize that. We'll find out soon. And let's do pi over 3. Pi over. Come on. Cool. So that, in theory, I don't know what a pi/3 rotation around 111 is, but we should end up with some kind of weird rotated set of planes. Yeah, so that's some kind of rotation there. Let's make one of these a different colour. Which you can do like that. That rotation might have been a... I can't really see. I feel like I've managed to get that perfect. That I don't know if there is any overlap there. So let's try a smaller rotation. Building with 01, I wonder if this will be quicker with 00. Link times are really what's killing us. So yeah, so here we see like this doesn't look right at all. So this is completely paradoxical here. Like this red square is technically closer to the camera, yet the green square is being drawn over the top of it, and that simply happens because the green triangles, which are defined down here, are being rendered after the red triangles. So we fix that with a depth buffer. Let's see if we can work out how to get one of those set up. So let's go through this. So depth stencil attachment for our subpass. We had a color attachment, so I think we're definitely going to need something here. We need an attachment reference, so let's get a depth attachment reference. Let's try attachment 0. I'm not sure what's going to happen there. We're going to get a VK image layout. Where's the list of color attachments? Here we go. Depth stencil attachment optimal must only be used as a depth stencil attachment. Yeah, well that sounds right to me. So VK image layout depth stencil attachment optimal. VK attachment reference. That's a pointer, so I think I've got to do set VK ref. Ooh, good. So we should get a validation error here, because I haven't created the image view or anything for this. Straight to a segfault, that's nice. How do we do this? How do we bind all of this stuff? That's why we create a frame buffer. I don't think it's really part of the frame buffer though. What about if we change that to definitely going to need this anyway, which is the depth stencil create info. And that's part of our pipeline creation, which is not where I am. Right, it's a bit easier to see now. So that was P depth stencil state, and we need to set that. Depth stencil state. So I don't know if these are, I imagine these are 0, 1. I might need to check this against the tutorial. Let's do normal set flags. 0, Pnex goes to null. Depth test enable true. Depth right enable. Wonder if I'm going to have a. I could probably do that in a single subclass. I'm wondering if I'm meant to have multiple subclasses, one as like a depth only pass. Might do that later. See if we can get away with it for now. Depth right, yes please. Depth compare. So I want to keep fragments. Yeah. Keep fragments that compare less than or equal to what is currently in the depth buffer. Front and back control parameters, I don't know what this is. We're not going to use the stencil test. Can it be null? Please tell me it can be null. I don't want to fill all that out. Oh, for God's sake. great. I had to set the entire thing. Compare or well, yeah, whatever. It doesn't matter because I'm not using this. So. Oh, they're going to be stencil ops. Like that. Okay, so now we've got some depth stencil state. So I'm going to guess basically that we've probably got to create an image view for this. But what's somewhat odd to me, so we've got all these images, we've got all these frame buffers. Oh, does it go? Is it part of a frame buffer? Probably is actually. That's generally where your attachments lie. Feel like I should there frame buffers. Yeah, so frame buffer has a bunch of attachments. Yeah, okay, so yeah, let's do our depth view as well. So for every image we got from the swap chain, we also need to create an image for our depth buffer. Right, so how do we create a depth image? So last time we just got given these images because they came to us from the swap chain. We're not going to have that luxury this time. So it's a managed Vulkan resource allocated with VK create image device. There's some create info and we'll destroy that image on termination. big this thing. Impossible to scroll it. Needs an image type. Yeah, what's that error? Okay. I'm gonna guess R, do you like R16 R16S float? Yeah. So that's a single channel sine float basically. And that's the first float. Yeah, that makes sense. I feel like we've seen this initial layout thing before. Initial layout isn't set, so it's a typo. I think we can do null pointer here. As long as we set key family index to 0. Sharing mode, multiple key families, we don't have that. Tiling. That sounds good. We don't really care how it's laid out in memory. Have we ever had to specify samples? We have. We did sample count one bit. I guess it's got one array layer. One MIP level. That's just quickly turn those notifications off. Right. So we need some like 3D extent. I'm actually going to pass in the extent of our main image. Hence the to do that, because obviously we're not going to have this 0 by 0, that doesn't make any sense. But I don't know what to do about the depth. Maybe it's just 1. Format. We're going to pass that in. I hope we have to create one of these images. It's going to be annoying if not. Maybe there's something. Depth must be greater than 0. That's the only mention of it. Is that everything? Surely I have to allocate like memory for this image as well. Whoa, it looks like we've got a lot of stuff here. Okay, create random pass. Color attachment 1 must be less than... Right, so... Did I not... Color attachment one. Wow, that's pretty funky. What the hell's gone on there? I guess it's because it's not cleared, so it's only... That's really cool. It's not at all what we want. I got a bunch of validation errors still, so... VK format for tiling optimal does not support requested image usage. Spec states if tiling is VK image tiling optimal and so I can't use that one, I guess. Create image extents exceed allowable limits for format. Gotta find like a usable depth format. Wonder if there's a VK info? Vulkan info. I'm going to cheat a little bit here. Come back to this. Just want to see if I can get something working. Ah, there's this D16 thing. That sounds likely. Let's try that. Ah, I'll go back to optimal then. Yeah, okay, so we can only use D16 with optimal tiling. initial layout must be undefined. VK initial layout, VK image layout undefined. Okay, that makes sense. It initially starts out undefined. VK create image view used with no memory bound. Memory should be bound by calling VK bind image memory. Right, so I need to allocate some memory for this image. That's fine, we've done that before. So yeah. How do I get the memory requirements? Get image memory requirements, cool. To determine the memory requirements for an image resource which is not created with disjoint, okay. Needs a device, and an image, and that's it. So, how do we usually do this then? This. Physical device comes first. Okay, don't know what that is. Probably just Vulkan VK device memory. Looks like it does need device as well. Okay, VK applied image memory. Okay, so now our image should have some memory. How long have I been using Haskell? I think they're actually coming up to saying like 6 years or something now. So I've got a blog over at ocharles.org.uk/blog. And this is really when I kind of started. I started with this advent calendar called 24 Days of Hackage back in 2012. And that's when I was like really becoming proficient with Haskell, I'd say. So yeah, that's 6 years now. Wow. Didn't really realise it was that long. Depth only image formats must have image aspect depth bit set. Is that something that goes in here? No, it's not going to be that. Depth only image formats must have. This is in VK create. VK create image view takes some VK image view create info. Here we are. Aha. Let's stick it in as a parameter again. What have I got wrong? What do you want? What other things did we get? Attachment count of 2 does not match attachment count of 1 of render pass used to be. So that was in create frame buffer. There are definitely going to be 2 attachments there. So that thing seems to be correct. It's the render pass that we got wrong then. Okay, so render pass. Has an attachment count of 2. So I guess what uses that? Subpass. Just literally stick that in, copy and paste, exactly the same. It does look sensible, right? I guess the format's the only thing that's going to be wrong here. It contained previously. Yeah, so this is the format thing that we just caught. Frame buffer attachment 0 conflicts with the image's image usage flags. That's when we created frame buffers. Did I get these the wrong way around? I must have. So color and then depth. Color and then depth. Could it be? I want to did the render pass, is it? Something's gone screwy with these attachments. Oh, where's that frame buffer gone? No, not going to be there. Frame buffer's really simple. Oh, it does take a render pass, doesn't it? Right, all the tutorial time is on. We seem to be stumped. Yeah, we've kind of seen all of this stuff. So yeah, create image. Where's... Oh, I guess I did that in another chapter, which is a bit annoying. Yep, we had to do that as well. Right, so we get this attachment description. That's this. Oh. Gonna need that. And then this goes to attachment 1. Okay, so that was, I think, where it's complaining that we're using something with colour and depth. Then a subpass, they set the colour attachment and the depth. Yep. Then when you create the render pass, you say it's got 2, put that in, yeah. It's progress-ish. Yeah, it's just these clear values, I think, then. Clear value. Yeah. With the depth to 1. Maybe that's enough. Nope, we've got to set stents. bump that up. Alright, bingo! So that now is a correctly depth tested rendering. So you can see here that the red plane is now on top of the green plane, which completely makes sense because the red plane is the one that's closest to the camera. That wasn't too bad. We do have a little bit more work to do, which I'm not going to do today. We're accumulating quite a lot of correctness stuff. So at some point we're going to have to do this, which is correctly determine the format of the depth buffer. So I've hard coded that to a depth format that pretty much every graphics card I've ever seen supports. Where is it? Yeah, D16 Unorm. Like, if you've got a graphics card that doesn't support 16-bit depth buffers, then you're not going to be rendering Quake 3 maps. But of course, I suppose stuff might not support 16, but could support 24-bit or 32-bit depth buffers. So we should test this. Anyway, I'm going to wrap the stream up there. That's a nice place to stop. This is looking good. The reason this is quite interesting now is I think we've got all the machinery to load a Quake 3 BSP in the next stream, which is probably going to be on Saturday. I don't have any plans on Saturday, so that seems like a nice thing to do in the day. But yeah, so we've got, what have we got? We can upload vertices, we can upload indices, and we can do depth buffering. We'll need to change our vertex format to support UVs and stuff. We don't have any support for texturing, but that's okay because texturing is going to be quite a complicated part because we're going to have to pass the Quake 3 shader model. But we should be able to just like stick a map up and maybe render its UVs or something like that. It's quite a nice way to get some sense of depth and not just have a big flat image. Anyway, that's enough rambling. I'm going to wrap that up there. Cheers for joining me, everyone. And yeah, next stream's going to be on Saturday, I think. So if you're interested in following that, follow me on Twitch or just follow me on Twitter because I tend to tweet when I'm going live there. Cool. Cheers for joining me.